logarithm is an inverse of a power. So if we have y equals 10 to the x, which is a power, and that's graphed right there, we could take each of the values, switch x and y, flip it over the line y equals x, and the graph that you would get is the inverse of y equals 10 to the x. So how do we write the inverse as an equation? We write it as log base 10 of x. So if your original graph was 2 to the x, then your inverse would be log base 2 of x. If it was original graph was 3 to the x, the inverse would be log base 3 of x. Now, with the base 10, it's considered special. It's called the common logarithm. And they decided with a base of 10, you can write it without the 10. On your calculator, the log button that you have, if it says log, it has a base of 10. Okay? So watch a couple of things on your calculator. Whoops. Obviously, 10 squared is 100. Now, if I do log of 100, I get 2. 10 cubed is 1,000. If I do log of 1,000, I get 3. What do you think log of 10 million would be? Seven. Because 10 million is 10 to the 7. So we see that logarithms solve for exponents. If you have log base 10 of 10 million, the exponent would have been 7 to make that happen. Any guesses what? Let's just go. Any guesses what this would equal? Log 2 of 8. Push enter. Okay, see if you can start to figure out how logs work. How about log base 5 of 25? So we'll come back to this, something to think about. We've got our common logarithm. And on the next slide, we've got 10 to the 0 gives us 0, 1, 10 to the 1, 1, 10, 2, 100. And on your inverse graph, you switch x and y. And at the bottom of your page is the definition of a logarithm. And this is really, really important. So what we have, and I've sort of explained it further underneath, is you have an exponential form of an equation which has a base and exponent is equal to y. This form can be changed and written in log form. So what that allows me to do is sometimes you'll know the answer, okay? 5 to the x equals 25. You can just look at that one and tell me what x is. You know that x is 2. But if I write that in log form it says this would be log 5 of 25 equals x. On the left-hand side, in exponential form, you're just using your powers chart, and you know that one. You like look at it and say, I know that it's 2. But on the right-hand side, it means the same thing, and the right-hand side, we just typed that into our calculator, and our calculator told it to us. So now we can do stuff on the left side. Ten to the x equals 150. And now our brain shuts down, because we know 10 squared is 100, 10 cubed is 1,000, but we don't know what is 150. But we can change this and write it in log form. So the base goes there, the answer goes inside, and logs always solve for exponents. Now I can type this into my calculator. Log 150. Notice when you use the log button, a base doesn't need to be written, and it means a base of 10. If you have a newer graphing calculator, it will allow you to do logs of different bases. Most calculators only let you do a log of base 10. So whichever scientific calculator you decide to get for your final exam, you might want to check, does the scientific calculator I have let me do different bases? Or does it just let me do a base of 10? Anyways, I push enter, it's 2.176. Check it out, 10 to the power 2.17609, 1259. It equals 150. That would have been very hard to do mental math, especially that final 5 and 9. No, all of it would be hard. And so a logarithm is another function that's built in your calculator that knows all of these values, ones that you can't do in your head. Just like sine, cosine, tangent. If you have a triangle that you don't recognize, you can't just see and say, I know exactly what that angle is. But if you use your calculator and do sine inverse of 4 over 7 or whatever the number is, your calculator has it built in and tells you what the angle is. Same thing with exponents. I can't easily figure out what 10 to the x equals 150 is, but my calculator has it built in. If I write it as a log, which is the inverse, it'll figure it out for me. Okay, so here's our first example. Part A, it's just working with the definition. All of those are exponential expressions. What we need to do is to write them as log expressions. So, a reminder of our definition. There's your exponential form. You just have to write things in a different order. The base is still the base of the log. Logs, the way that I remember it is I say, well, logs help me solve for exponents. So the equals is always the exponent on the other side. And then the only other thing would be the answer. So 3 to the 3 equals 27. That's the same as writing this. And the second one? I'm going to write the -2 on the other side in a second. Hey.
You good then?
Yeah, I'm good.
They know what they're doing. So.
All right. Sounds good. I might have to go see Krista for a little bit during it, but that should be fine. Okay. Yeah, no problem. So I'm going to write the -2 on the other side, but one of the things you're going to eventually be asked is you're going to get a question like this and say, mental math, can you figure out what's going to go on the other side? So what you're going to do is you're going to say, okay, I know my base is 5. I'm solving for an exponent, and I need it to equal 1 over 25. If you think of it this way, because you're more used to powers, you're going to be able to say, hey, it has to be minus 2. Because 5 to the minus 2 is like 1 over 5 squared, which is 1 over 25. And part 3, 4 to the 0 equals 1, so log base 4 of 1 equals 0. Now we have the logs. We write them in exponential form. For I, the base is 7. The exponent is 2. Answer is 49. The base is 4. The exponent is negative 3. Base is 10. Exponent's negative 4. So try 5, 6, and 8. As in any subjects, when you learn a definition, it's very important that you memorize it and get to understand it really well. So now you've been introduced to a logarithm. This needs to be memorized. You really have to know the definition well, and you have to be able to switch back and forth easily.